So this was the one we handed in. The first one here was asking for what values does k have to be to get the same remainder. So what it meant was that we need to make sure that when we plug in 1 and when we plug in -2, because that's the solved version of those, we should get the same answer. So they should be equal to each other. So what I did was at the top here, I plugged in 1, simplified it. I plugged in -2, simplified it, and then I solved for k. So it's nice because it's a nice linear that you've seen way back when, a linear with an x on both sides. We saw that definitely in grade 9 and for sure in grade 10 as well. With this one, it was tricky because of the wording of it. The container has the container is 4 times as wide as it is deep and 5 centimeters taller than it is wide. So when you're looking at that, if the width is the width, then the length is going to be 4 times that, and the height is 4 times that plus 5. And then when you work that out, you expand this out, you would get this cubic. I brought the 2500 over, and then what you want to do is here I plugged in, let's write that down, f at 5, and then that told me that 5 was one of the factors, so then I can go there, and then if this was, what I did here was I did a quick synthetic division of this to get the next part, and this is not factorable, so I know that my width is 5, my length is that, and my height is that. To check if it's divisible, there are 2 ways of doing this. You can actually divide them out, and I saw that there was no remainder, so that's where did the long division, or if you want to do the synthetic division on that, you can't, because you can only do synthetic division on a linear part, not like a linear to a polynomial, not a polynomial to polynomial. And then the other way that I saw, so I wrote it down as well, was if you factor out your second one, you get x plus 3 and x minus 4, and then what I did was I just used the factor theorem and plugged in those 2 parts there, and because they are factorable by that, it would tell me that there's going to be no remainder left over. And again, this one here is very similar. Determine the value of k when you divide it by x plus 2, and you find the remainder is 1. So I plugged in -2, and then I solved for k. That is the easiest way of doing it. If you try to do long division or synthetic division on this, what you're going to end up with is more confusing work with that, because you're going to be trying to figure out how in the world do I make my leading coefficient k, and there's like too many k's in there, and it'll look really awkward. So your best part is using the factor or remainder theorem for these types of questions. And the last one, you had a shipping container, it's 30 by 20, and then it's asking for the dimensions, but we're going to cut out corners. So each corner is going to be missing a little, let's say, x from it. They're all the same. So the 30 length is missing 2 x's from it. The 20 width is missing 2 x's from it, and that would make the height now x. And we know that volume is just length times width times height. So I plug that in, I plug in my volume, I move things over, and then I start factoring it. And then I go through again, I go through my factor theorem to find out which one is a factor. And you could do this continuously to see what other ones work. If they all worked out nicely, and this time you're going to see here, the other 2 do not work out nicely. So when you find the first one, I did some synthetic division. You could do long division here, and then you could use the quadratic formula here, because this is not nicely factorable. And then the only trick here is that if you plug in 17.1, well, 2 times 17.1 is 34.2. That's going to give me a negative width. So that cannot happen. Same thing with length. So 17.1 cannot work because the there are multiple pieces that become negative, so the only two answers are that x has got to be 3 centimeters or the 4.9 centimeters, where that's the cutout part.